In this video, we're going to talk about primitive values and objects in JavaScript, and we're going to see how all of that relates to prototypal inheritance. Now, we've already spent plenty of time talking about objects and we know how they work, but we're going to see them in a completely new light. I've never mentioned the word primitive before, so we'll be discussing exactly what those are as well, and the good news is that they're already things you're familiar with. Over inside of the JS Bootcamp folder, we're going to make a new directory. We're going to move over to a web app as opposed to just running scripts from the Node terminal. Right here, eventually we will create a little web app for the Hangman game. So let's call this folder Hangman. And in there, we're just going to add two files real quick before we start discussing things. We need an index.html file. In here, we can set up the doc type. Doc type HTML. Then we set up the HTML tag. We add our head inside of HTML. We add the body inside of HTML. And all we're going to do is set up a script tag. So script, we'll set up the source attribute. And let's just say that we're going to put a file in the Hangman folder called app.js. Excellent. So let's go ahead and actually create that file, start the server, and we'll be able to mess around with a lot of the stuff that I want to talk about. In the Hangman folder, that's app.js. And in app.js, we will kick things off in just a second. What I want to do first is start up the server. So over here, I am going to cd out of the OOP directory, and I am going to use live server to serve up the Hangman folder. Awesome. So now things should be up and running. My page opened up in a different browser window on my other monitor. So down below, I can close these. We'll bring them back later, and I can navigate to that. For me, it's 127.0.0.1, port 56496. Your port is going to be different, so make sure to grab that instead. Now we're going to crack open the console, and I'm going to move it to the bottom of the screen. And there we go. We have our entire setup in place. Now it's time to dive in to what I really want to talk about. What I want to talk about is what happens when we have things like the following. When we have a string, and then we access what looks like an object property on it to call a method like split. We've seen code like this work plenty of times before, but it's not quite clear what's going on behind the scenes and how all of this relates to prototypal inheritance. So that's what I would like to start uncovering, and we're going to kick things off with something that we are familiar with. We're going to make a simple object. Const, we can make this object something like product. And to keep things a little interesting, let's just add at least one property on there, name. And let's say the product is a book we're selling. What book am I currently reading? I'm reading a book called Influence. Perfect. And then down below, what we're going to do is use a method on objects that we have not used before. Right here, that method is called hasOwnProperty. It returns true or false. We can check if an object has a property by providing that property name as an argument. If that property exists on the object, it returns true. If the property doesn't exist, it returns false. Pretty straightforward. So let's go ahead and actually use it. Down below, we'll set up console.log to print the output to the console so we can see what comes back. Then on our object, which is product, we are going to access hasOwnProperty. Then what we're going to do is call it as a function, which it is, and we're going to pass to it the one argument it expects, a string with the property name we're looking for. So we could look for one that does indeed exist, like name. If I run the code, the browser refreshes, we get true. If I check for one that does not exist, like price, for example, the browser is going to refresh and we're going to get false. So clearly, hasOwnProperty does indeed seem to function correctly. Now the question has to be asked, why is it called hasOwnProperty? Why not just hasProperty? To start exploring this and to uncover what I really want to talk about, let's take this method name, copy it to the clipboard, and then paste it as the thing we're searching for. If we run this code, we're actually going to get false, which doesn't really make sense, since we know that hasOwnProperty exists. The function is running. So we're basically checking if the function we're running exists, and we're getting back false, meaning that the code should fail, right? It should say that the function doesn't exist when we try to call things. This is very confusing behavior, but to uncover what's really happening and to have all of this make a lot of sense, what we're going to do is pull up the documentation for hasOwnProperty. Over here in the browser, I'm going to search for MDN, then right here hasOwnProperty. And when I do, we're going to see the first result is the one we're looking for, and you'll notice something right away about that title. It's object, capital O, dot prototype dot has own property. So internally, when we're using these data types we've been exploring, we are accessing those shared methods like filter, split, and others such as has own property via prototypal inheritance. So let's see what this actually looks like. Right here, I'm going to outline the little tree, the prototype chain for the product object. Now, as we saw in the slide for the last video with one of our other examples, for example, one of the person instances, we first look for things on the instance itself. If we don't find it there, we look for it on person.prototype. If we don't find it there, then it's nowhere, and then we get undefined back. The same thing is true over here, but with a prototype that we did not create, one that's built into the language. So we start by looking at product. Does product have what we're looking for? If it does, great, that's what we want. If not, we actually continue up the prototype chain using that internal prototype property. This time, though, the thing that we get linked to isn't something we created. It is object.prototype. Now, object.prototype is where methods like has own property live. So that's why we're able to access them on our object product, even though the only thing we've set up is the property name. Now, technically, object.prototype also has a prototype value as well, and this prototype value is just null. This means the chain ends. So we search here. If we find it, great. If not, we search here. If we find it, great. If not, then we search here, and we're never going to find it on null, so the chain ends and we stop looking for more stuff. So this is a completely accurate depiction of why code like this runs. Now we can figure out why it's has own property instead of has property. Has own property lets us check if a given property exists on that thing, product, not somewhere up its prototype chain. So can we access product.hasOwnProperty? Yes, we search up the chain looking for it. But does it exist on product itself? The answer to that is no. So product does not have its own property, has own property, that exists somewhere up the chain. Using the browser, we can actually visually explore the prototype chain for anything by dumping it to the console. So that's why I switched us over to the browser. Right here, console.log, and we're just going to log out product itself. Let's save the file and see what we get. Over here, as the second output, we have our object, like we've seen anytime we've printed an object to the console. But now we see that this notation is very similar to the notation we had in previous videos when we printed out an instance of person or an instance of hangman. It first started with the constructor function name. In the case of person, it was uppercase P person. And then we had our curly braces, and in there we had all of the instance properties we set up. The same thing is true with object, because by using this notation, we've successfully created a new instance of object. Now, if we expand that, what do we see? We see name, which we set up, and we also see this other thing. It's __proto__. Now, in previous videos, I had mentioned that the thing that links your instance to the prototype property is this guy. It was 2 opening brackets, uppercase P prototype, 2 closing brackets, and that is true, but that's for internal use only. The browser exposes this property so you can view the prototype chain. Although we're never going to manually manipulate it, and very rarely, actually never, will we ever use it in our code, but it does serve a great purpose when it comes to exploring how things work. If we expand this, what do we see? We see we get an object with various properties on it, one of them being the method we just used, has own property. So what we're seeing here is all of the stuff defined right on here. Now we can go ahead and take this one step further. Does this thing, the thing that starts at defined getter and ends at value of, have __proto__? And the answer is no. And that lines up with what we explored over here. Product has stuff on its prototype, but object.prototype does not. It is null. Now we could even prove that further by accessing product right here. Product prints as expected. We access product.__proto__. What do we get? We get the object prototype. I'm going to reload that last command using the up arrow, and I'll add on one more underscore underscore proto underscore underscore. So we're accessing product.proto.proto, and what do we get for that? We get null. So right here, we can see that prototype chain in action. This is exactly what's happening when we create product and we try to access properties on it. Now, much like we can change person.prototype and hangman.prototype to customize the behavior of the instances, we actually can change object.prototype. We could add new methods on, or we could override existing ones. This is generally a horrible idea, and you're never actually going to do it, but it is going to help us explore how all of this works. So for example, we have object.prototype, and I can indeed set something on there. Let's actually override hasOwnProperty, the one method we're currently using. All I'm going to do is set this up to be a function. I'll use the shorthand arrow function syntax, and we're just going to return a string. This is the new function. So if we see this is the new function, we know we successfully overrode it. If we see true or false, which is what normally prints, then we know we did not override it. I'm going to save app.js, and what are we getting over here? I'm getting this is the new function. So using this code, we were able to override the behavior of one of those default methods. Once again, something we're not going to be doing, but I just want to show you this to show you the similarities between what we've already done and understand and how JavaScript works behind the scenes. We could also add a brand new method onto all of our objects, some new method. Now we're going to be able to access that on every single object we work with. So down here, for example, I could replace hasOwnProperty with a call to some new method. And just like we got before, we're going to see our string print. This is the new function is printing. This method previously did not exist. You're not going to find it anywhere in the documentation, but by overriding the prototype, we were able to get it to show up. There's one last thing about this example which does not make sense. Typically, when we wanted to use prototypal inheritance, we had to use the new operator with our constructor function. That's what we saw for person and for hangman. If I wanted to create a new version of the game, I would use new with the constructor function. I would get back my initial object, and that initial object would have access via inheritance to things from hangman.prototype, like getPuzzle. Here we're seeing that same behavior. Our object has access to things off of object.prototype, like hasOwnProperty, but at no point have we used the new operator with the constructor function. Well, this is because how we're creating the object here, this is known as a literal syntax, when the syntax of the language allows us to define a value of a specific type using a series of characters. Here, those series of characters would be the opening and closing braces with our name on the left-hand side, a colon, and the value on the right-hand side. The language is able to see this syntax and interpret it, knowing that what we're really trying to do is create a new object. So it handles that for us behind the scenes. That's why we do not have the new operator, and we do not use the object constructor function. This is not to say there is no object constructor function, because there is. Right here, we can remove the literal syntax, and I can create a new object using new object. Then, like we're able to do for any object, we can add on properties. So what we've done above is very similar to just setting product equal to this, an empty object. Let's go ahead and set up a property, product.name. I'll pick a different book. I read a book called Rest recently that was good. And if we save the file, what are we going to see? We're going to see exactly what we had before, just the value for the name property has changed. It's still an object. It's just been created using a completely different syntax. Here we are explicitly using new with the constructor function, as opposed to having that implicitly done behind the scenes when we use the literal syntax. Now you can initialize objects with values if you're using the constructor function. All we do is we provide the object as the first and only argument. So we could say we want to start off with a name property, and then we can just pick a different book that I've read recently. Let's go ahead and use the War of Art, for example. If I save the file in its current state, we still get an object, we still have our name property, only the value has changed. So those are all different ways we can create objects in JavaScript, though we're never going to use this syntax for getting it done, since we have the object literal syntax, since it is a built-in type. The language knows what to do with those series of characters, which means that we can avoid stuff like this. All right, now that we've seen how objects work, we've explored a lot of the detail. We've seen what goes on behind the scenes for these built-in types. In the next video, we're going to see how the same thing applies to all of the other types in the language. Then I promise we'll be all done with the theory side of things, and we can get back to actually building the Hangman game. But understanding how this works is super important, so I do ask that you stick with me. If this video didn't make a whole lot of sense, my recommendation is to go back to the beginning and just watch it one more time. I think it'll start to stick once you know what's coming up and once you can let that information sink in and start making relationships between the different pieces of the puzzle. So that's where we're going to stop for this one. Let's take a quick moment to recap. In this video, we learned that when we make an object, we are still taking advantage of prototypal inheritance. That is why on our objects, we're able to access things like hasOwnProperty, something we never set up. That is because all of our objects are linked to object.prototype, which is linked to null. So here we're seeing the prototype chain for objects. In the next video, we're going to explore the prototype chain for everything else. For example, on arrays, we have filter. How exactly does that come about? We'll dive into the details, so stay tuned and I'll see you then.